This video is about the derivative of sine x, cos x and tan x. So here on the first slide I've got three rules. First of all, the derivative of sine x is cos x. The derivative of cos x is neg sine x or negative sine x. The derivative of tan x is 1 over cos squared x, or as it's sometimes known, sec squared x. Handy here to revise, or here for the first time maybe, the inverse trig operations. So we've got three of them. We've got sec, cosec and cotangent, or sometimes abbreviated to cot. Sec equals 1 over cos. Cosec equals 1 over sine. And cot equals 1 over tan. So the inverse operations of the three trig functions. Now the way I used to remember them myself at school is it's all around the third letter. The third letter of sec is C for 1 over cos. The third letter of cosec is S for 1 over sine. And the third letter for cot is T for 1 over tan. So always look at the third letter of each of the ones. Anyway, we're dealing here with sec. So the derivative of tan x is 1 over cos squared x or sec squared x. Okay, so let's have a look here at one of our derivatives of trig, and I'm going to use the chain rule here just to show that you can. There's often shortcuts that mean that you don't have to use the chain rule, but let's have a look at this anyway. So if I was using the chain rule here, and usually of course with the chain rule we make our substitution of u, so this would be sine u, okay, and we've let u equal 5x. So u equals 5x, y equals sine u. So du dx equals the derivative of 5x is 5, to y du, the derivative of sine u is cos u. Remembering back to our derivatives rules that the derivative of sine is cos. Okay. Oops. So we multiply those together now, and dy dx equals 5 cos u equals 5 cos, and u is 5x, so it's 5 cos 5x. There you go. So the derivative of sine x is 5 cos 5x. Now you might be able to see straight away there a shortcut, even after just one example. And the shortcut, if you might have recognised it, is that you get the derivative of 5x, put it out the front, to 5, change sine to cos, and that part there, the 5x, stays the same. Okay, so that's it. Let's work through that again. So here's the shorter way. Dy dx equals the derivative of 5x, which is 5. Sine changes to cos, the 5x stays the same. So if I asked you the derivative of y equals, let me see, cosine 2x squared plus 5x, same sort of rule. Okay, so dy dx, derivative of the bracket, 4x plus 5. Now cos changes to sine, and it's negative sine. Going back to our rules, where you've got to be careful. The derivative of sine is cos, but the derivative of cos is negative sine. So here we'd get negative sine. So what I'd do there is bracket that and put the negative there, and it changes to sine. So that gives me my negative and my sine. And then the bracket stays the same. 2x squared plus 5x. So there's the answer. Derivative of the bracket out the front. Cos goes to neg sine, and I've put the neg there instead of next to the sine. And the bracket stays the same. Alright, here's the same rules that I was just using in official form. So here we go. If f of x equals sine of a function, sine of g of x, then the derivative is the derivative of that function. Sine changes to cos, same function. If the original function is cosine of some function, then the derivative of that function is the derivative of g of x. Cos changes to sine, negative sine, remember, so there's a negative out the front, and g of x stays the same. Tan, it's a little bit trickier. There's two versions here. If f of x equals tan of a certain function, then the derivative is the derivative of that function, g of x, over cosine squared, same function. Or the derivative of the function, sec squared, the same function. Let's use them a bit more. Okay, let's look at tan 3x. And I've put next to it here, I've just cut and pasted over the rule for tan. And we'll do both versions, the cos squared version and the sec squared version. Here we go. Derivative to y dx equals derivative of 3x. Okay, so here, if you're looking at this rule, our g of x there is 3x. Okay, there it is. Okay, so using our rule on top, we've got the derivative of the bracket, which in this case is 3 over cos squared, the original function, 3x. The derivative of the function over cos squared of that function. Or, if we're using the other version, it's the derivative of the function, sec squared, same function. So compare the two rules there and look at my answers. You can pause the video at this stage if you're a bit unclear. Harder one now, this time it's a cosine one. Once again to the side, I've put in the rule that we just looked at. Alright, so dy dx equals derivative of the function g of x is x squared plus 2x minus 3. The derivative of that is 2x plus 2. Okay, now we've got cosine going to neg sine, so it's neg 2x plus 2, sine, bracket stays the same. Last step here is to factorise the bracket on the outside. So we take 2 out, and if we do that, we get negative 2 outside of x plus 1, sine x squared plus 2x minus 3. Once again, there's the same rule. Cos changes to negative sign, so cos to negative sign, there's the negative. Derivative of the bracket goes out the front, bracket stays the same. Find the gradient of the curve. G of x equals 2 cos x cubed minus 3x at the point where x equals 0. As I pointed out in my last video, to find the gradient at any point, you sub the x coordinate into the derivative. So the first thing we've got to find here is g dash of x. Okay, so the 2 stays out the front. We get the derivative of the bracket, which is going to be 3x squared minus 3. We go to sine from cos, and it's negative sine, so we pop a negative 2 out there. Bracket stays the same. Bit of tidying up to do here by taking the 3 out of the bracket. So remember, 3x squared minus 3 factorised into 3 outside of x squared minus 1. So if the 3 pops out there, instead of negative 2 there, we've got negative 2 times 3, which is negative 6 outside of x squared minus 1. Sine x cubed minus 3x. So there's our g dash of x. Now to find, actually we'll just copy that over the next slide so I've got some more room. Now we have to find the gradient at x equals 0. So what we're after here is g dash of 0 equals negative 6. Oops, sorry. Negative 6 outside of 0 squared minus 1 sine 0 cubed minus 3 times 0 equals negative 6 times negative 1 is 6 sine 0. And sine 0 is 0, so 6 times 0 equals 0. Alrighty, there's a bit of a start there on the derivatives of sine, cos and tan. That enables you now to do exercise 7G. Hope that's okay, and that's all for now. 10 minutes.